In this video, we're going to take a look at several examples of geometric series. Remember, from Algebra 2, a geometric series is in the form of a(r) to the k. Remember that if the absolute value of r is less than 1, then the series will converge. And if the absolute value of r is greater than or equal to 1, the series will diverge. So, very important information there. So converge or diverge, and here we have from 1 to infinity of 1 over 2 to the n. Well, one of the tricks that we know is that 1 to any power is still 1. So we're allowed to go ahead and put our own n to the top, thus rewriting the series as n is 1 to infinity of take out the n, and we have 1/2 to the n power. Well, now clearly r is 1/2. 1/2 is less than 1. Therefore, this series does converge, and we can find the sum. To find the first term, take the bottom limit, plug in to the original. If we plug into the original, we would get 1/2 as our first term. Remember, the formula for converge of a geometric is first term over 1 minus r. On the bottom, we have 1 minus a 1/2. That would give us 1/2 over 1/2, which would be 1, which is our sum. Pretty simple example. In example 2, we've learned that if we don't like this 3, we can think of it by pulling it out a little bit. So we could rewrite this as n is 0 to infinity, 3. Well, now we've got the same situation as we had before. We have 1 over 2 to the n. We can put our own n, rewrite this series as n is 0 to infinity, 3, 1/2 to the n. Well, now once again, r is 1/2, so this series converges because 1/2 is less than 1. So let's plug in the first term. If we plug in the 0, anything to the 0 power is 1. So we have 3 times 1 is 3, which is our first term. So we have 3 over 1 minus 1/2. That would be 3 over 1/2, which would be 6 as our sum. In our third example, again, this is geometric. It's in the form of a(r) to the k, but this time r being 3/2. Well, that's greater than 1, so this one automatically diverges. In example 4, this one's a little more complex and will require a little bit of work on our part. So if I have 1 minus n, that's the same thing as taking out a negative and reversing it. Well, now I've got a negative exponent, 3 to the negative n minus 1. We could put that on the bottom of a fraction, rewrite as n is 1 to infinity. Now, 2 to the 2n, I'm going to think of that as 2 squared to the n. On the bottom, I have 3 to the n minus 1. Well, that's looking a little bit better, but let's go ahead and see what we can do about this 3n minus 1. Could rewrite that as 3 to the n times 3 to the negative 1. Now I've got this negative exponent that can move to the top. So now let's rewrite that as sum from 1 to infinity. I've got a 3 on the outside. On the inside now I've got 2 squared, which is 4. I've got 3 on the bottom to the n power. Well, if we stare at that, notice now that r is 4/3. That's greater than 1. This thing diverges. In example 5. In example 5, again, we need to take care of a little bit of business here. We've got n minus 1 there. So let's think of that as 2/3 to the n times 2/3 to the negative 1. Well, to the negative 1 power means multiply by the reciprocal. So on the outside, I've got a 5. I'm going to multiply by 3/2, and then I've got a 2/3 to the n. Well, so we can rewrite this. N is 1 to infinity of 15 over 2 times 2/3 to the n. Well, clearly R is 2/3, so that's definitely less than 1, so this thing is going to converge. So we want to find the sum. So let's go back to the beginning. If we plug in the lower limit, we get anything to the 0 power is 1, so 5 times 1 is 5. So our first term is 5, 1 minus 2/3, so that's going to be 5 divided by 1/3, which will give us an answer of 15. Let's go ahead and do one more problem. So in this one, again on the top we can clean that up as negative 3 to the n times negative 3 to the negative 1 power over 4 to the n. Now this negative 3 to the negative 1 power would go to the bottom of a fraction, so we could rewrite this as n is 1 to infinity of 1/3. On the inside we've got a negative 3 over 4 to the n, so we were allowed to pull that n out. R is negative 3/4. Negative 3/4 is definitely, the absolute value of that is definitely less than 1, so this thing is going to converge. So now we need to find our first term, plug in the lower limit. If I plug in the lower limit on the bottom, I get a 4. On the top, I get negative 3 to the 0 power. Anything to the 0 power is 1, so our first term is 1/4. 1 minus negative 3/4. So that would be 1/4 divided by 7/4, or 1/7.